So hello everyone. Today our last workshop with AWS, and we will talk about responsible AI. And my name is Anna Silvanen. I am from Women in AI Finland. Today we have also Salla. Salla will be presenting after me, and she is also from Women in AI. And we have Elena from AWS. Also Alison from AWS. And we have some people from our core team, so you can see from name we put if we are from Women in Finland. Here is the topic, and people still join. Nice. And information about our speakers. So Yelena Uzanovic, she will be presenting after Sala. Here is our agenda for today. And after all presentation, we will have labs. Elena, if you can share the link for labs to me also, I can put in our Q&A section. We have here in Zoom meeting, we have a Q&A section, and if you don't see now it is on your Zoom panel, or if you put this 3 dots more, so you can find it. I shared the links, useful links. So one of them is to our Women in our LinkedIn group, and another one was feedback as well. So please provide your feedback about this workshop so we can improve our workshops in future. And if you have any questions to our speakers, just type them here in Q&A section, or you can unmute yourself and just ask. We can answer them during the workshops. Here's also the feedback QR code, so you can scan and you go directly to this our feedback survey. I think it is all from my side, and Sala, you can start. Thank you.
All right, thank you, Anna. I will just share my slide set with you all. Let me just put it full screen. Do you see the presentation mode now?
Yeah, thank you.
Perfect. So, hello everyone. It's nice to be here with you all to talk about responsible AI. My name is Salla Westerstrand. I'm an AI designer at Solita, which is a Finnish IT consultancy if some of you come from somewhere else. I'm also a doctoral researcher at the University of Turku, researching AI ethics and its implications to democracy in a future ethics research group, and also AI ethics and communications lead at Women in AI Finland. So deeply working in responsible AI, ethical AI, and AI design, doing research and also responsible AI in practice. So today, I'm going to talk to you about what is responsible AI? How can we do AI right, or at least better than we do now? Just a couple of words about me, so you know who you're listening to. I'm a political scientist by background and also a linguist. And I currently help organizations to innovate, develop, and deploy AI ethically. And one thing I didn't mention, I'm also founder and AI ethicist at Harmless, which is my own consultancy, but now it's more or less on a break as I'm working for Solita to advance this mission. But yeah, so I don't have a background in tech, like in deep tech in that way, but currently, of course, I've transitioned to that field and applying all I've learned in political science, linguistics, and now doing the PhD in information system science. So that's where I approach ethical AI in practice. This first session we're going to have together is going to consist of these five points. I'm going to talk to you about what is responsible AI in the first place, a couple of concepts, and who does responsible AI in practice, and what are the tools and practices for that. And then we go to look into a couple of more precise tools or examples of tools. And of course, Jelena is then gonna talk about a little bit more from the perspective of AWS and their bias detection and mitigation tools and all that. And then I'm gonna end up with talking about how can we practice the actual skill of ethical decision making in responsible AI, and what that looks like in everyday life of practitioners. But let's first start with talking about responsible AI. Responsible AI is a quite vast concept, and like I've already talked about responsible AI, ethical AI, and my focus in my AI design work is sustainable AI. So we have quite a few different concepts that we can think about when we talk about how to do AI the right way, so to speak. So when you talk about responsible AI, we often think about who is responsible for the end result of AI systems and their consequences, and for what exactly are the different roles responsible for. That includes the concept of AI governance, so governing the whole process. But at the same time, we're talking about ethical AI, like what is morally right and wrong when we develop AI technologies or deploy AI technologies, when we use them in practice. How do we do it right so that they don't, for instance, what are the ethical problems in the first place? Are there biases? Can use of AI lead to discrimination? And how can we mitigate these risks? And on the other hand, what are the opportunities to support human flourishing and make our lives even better in a way to increase the ethicality of different systems? But also, we often talk about sustainable AI. That's one other concept that we often hear talk about. So how do we ensure value of AI systems in the long term? How do we sustain important societal structures that we have? What's the environmental impact of AI systems and these big, for instance, large language models? So how can we go beyond this AI hype and actually think about the value in long term? This is quite blunt description of responsible AI, ethical AI, sustainable AI. So as you can see, many of these questions are very much interlinked. So in a way, we could actually look at this picture more like this. So they actually, the middle part in the center is much larger than in this first picture. And in that large overlapping section, we have the quality AI, the high quality AI product that actually serves humans, is good for us, enhances our lives, even increases our life quality. So that's where the magic happens. And luckily for us, it's quite a large section there in the middle. It combines sustainable AI, ethical AI, responsible AI with their slightly different focus areas, but also they share the very goal of making quality AI systems that work for people and are also ethical, sustainable, responsible, all those aspects combined. So that's the focus of work in responsible AI, or any of these other titles that you might find around this this large topic. They all focus on that middle area to create quality AI systems that work for all. So in practice, these are if we think about how we do or where do we actually do ethical AI, these are some of the levels. So when we think about responsible AI in the strategic work, when we start to think about how we develop AI and what do we use it for, on a strategic level, we have to decide what are the principles, what are the goals and the mission that guide us towards the use of AI. Do we want to increase, for instance, efficiency of some processes by automating with AI? Do we want to maybe make better decisions assisted by AI systems? Can we even make more fairer decisions, more that are less biased. Of course, we humans are also in many ways biased in our decision making. So do we perhaps want to use AI for bias mitigation? So we have this strategic level where we think about these principles that guide our AI development towards a certain goal or mission. And it can often include principles such as justice or fairness, these kind of overall guidelines that direct our work towards certain goals and missions. At the same time, on the bit lower level, when we go in, if we think about for example, organizational hierarchy, more or less, then we have there the leadership level, the leadership, our managers, our directors, for instance, in a company, or in a public sector as well. There we have the responsibility to think about the culture. Do we have a culture that supports ethical thinking, for example, or revealing of biases or issues in AI development process? How about what kind of support we offer for our employees who are actually working in developing the AI systems or using the AI systems to offer services or products? And what kind of structures we have in place for example, whistleblowers to reveal some issues, potential issues, or bring new ideas to the game to make even better products with AI. So that's where leadership has a responsibility over ethical AI. Then, if we take it another step down in the hierarchy, let's say, we have workers, your everyday employees. Many of us are in that category. And there we can think about what are the practices when we develop AI or use AI? What are the tools that we can use to make better AI? And what are the individual choices? How can we practice the skill to make choices in a way that benefit humans, that are conscious of risks, that recognize the different issues in AI? And that's very interlinked also with the stakeholder level. When in all of these phases, strategy, leadership, working level, when you look into the broader audience that actually is impacted by our AI systems, that use the AI systems, somehow interact with the whole process of AI development and deployments. How can we make sure that these stakeholders are perhaps part of even the creation process with the co-creation methods, but at least have the agency to say, or have a agency in a way how the AI is developed in the end? So how can we make sure that people are actually independent actors, let's say, and preserve their freedom to live their life to their fullest, even when we have our AI and products in place? And lastly, I have governance there on the sideline, because it's kind of a concept that governs this process and the interaction between these layers, between strategy, leadership, workers, employees, and stakeholders. So it's kind of a process where we step a little bit back and look at this whole process of AI development and creation, and puts on the map the different processes and tools that we have in this entirety. And by the way, if you have at any point any questions, feel free to ask. I will check the Q&A in the end as well to make sure that I will answer to your questions. But right now I don't see those very well. So yeah, let's leave the questions at the end if you don't want to say them out loud. But let's go towards even more to the concrete level here. How do we do these different things in this level? What are the principles? How do we make them? What are the practices? What are the tools? So responsible AI is first of all done by finding these different tools. We have to find the different tools that we have already in place. There are many. But then the most important perhaps is to practice, and again, practice. So practice to use these tools, but also practice AI with your own brain, responsible AI with your own brain, let's say. Let's go a bit deeper into that after we discuss these tools. But first, let's take a look into the different kind of tool sets. For example, when we think about the worker level, the employee level, we can think about tools for bias mitigation that help us recognize perhaps the issues that could lead to discrimination, harmful discrimination of, say, minorities or different groups of people in society that are not that well represented in data sets, for example, or structural issues in our machine learning models that might lead into harmful outcomes, but also less good outcomes for some groups than others, let's say, even if it doesn't cause direct harm. We can also think about machine learning optimization. That's maybe something that is often thought about from the perspective of economical outcomes. How do we make it more cost effective? But that's also related to how can we make AI more environmentally friendly? And there, machine learning optimization also has a place. I wanted to take one example of from the Open Data Institute. They have a lot of great these kind of managerial tools for responsible AI processes and data-driven technologies in general. But here I've taken an example of data ethics canvas that any one of us could use in our own work. It doesn't even necessarily need to be you don't have to be a data scientist or data analyst or AI engineer, because you can think about the consequences and different aspects of AI systems you are interacting with in these different questions. I will leave a link after my presentation to these tools that I'm talking about, because of course this is terribly small fonts and you probably don't get a good picture of what these tools are about just by looking at them like this. So I will leave you the links in the comments after the presentation. And Jelena will tell you a lot more about bias mitigation and stuff that you can do with AWS as when you use AWS in machine learning. So I'm not going to go deeper into that. You will be able to practice it a bit later. Another example, when we think about the stakeholder level, when we think about how can we first of all recognize our stakeholders. This is also from Open Data Institute, this data ecosystem mapping canvas. They have these tools and instructions how to use this on their website. You can use data ecosystem map to map the different actors that you have in your data ecosystem. So, for instance, who is using data, who is impacted by it, whose data do you gather, and where are the data flows. So the data flows, basically you map the formal value exchanges, such as where the data physically moves from one place to another, where's the documentation, all these kind of questions. Then the next level would be to map the soft value exchanges, such as insights, knowledge, advice, feedback, that is not necessarily that well recorded, not that well documented, like the formal value exchanges between data. Because those play a big role in the actual data ecosystem eventually. And when you have done this mapping, you can actually find opportunities. Where do we have actors where the data flows are not necessarily as effective as they could be? Where is some knowledge that is not moving from one place to another? And these kind of, where could you collect more feedback than you currently do to actually make your AI more responsible or higher quality from the perspective of responsible AI? So these kind of tools are really, really useful with thinking about the stakeholder engagement. But as I said, this is just one example. We could think about all sorts of impact assessments that we have, and also risk analysis often takes into consideration the questions around data and privacy as well. So those are good kind of metrics to use to follow your responsible AI journey. But this is one example of how you could in practice take a better look at your stakeholders in your data ecosystem. And from the governance perspective, we have a lot of different solutions for AI governance platforms. And here is just two examples. You could use, for instance, Credo AIs or Cydos, which are the two ones here, Credo in the left and Cydos in the right. They both offer platforms that with which you can manage your AI, different parts of the process to make sure that it somewhat follows the or is responsible and follows a certain criteria defined by the platform. Usually they are very much related to safety and management of the data pipelines. This is one example from my own work, and this is now we are going to take a step towards more of the practicing side. How do you actually practice ethical thinking that is not necessarily tied to any physical tools? So, for instance, me as an AI designer, I often use design thinking phases as part of AI projects to, first of all, map the ecosystem. There I could use the ecosystem mapping tool to empathize with people in that ecosystem who use or are somehow affected by AI. I try to figure out what do we need to solve in this question, what are the needs that we need to solve, what brings actually value to these different stakeholders and users, and who else is impacted beyond the very direct end user. Using that information, we go to define the problem that we want to solve with AI, because we are not going to use AI just for the sake of AI, but actually we need to have a very clear goal that we want to improve with AI. When we have that problem, we move to ideation phase, we generate ideas, and here we could, for instance, use the data ethics canvas to figure out where are these ideas situated. Do we have some kind of issues with the ideas that might be identified using, for instance, the data ethics canvas or some kind of impact assessment tool? And then when we go to prototyping phase, we test the product or service and we see how it performs in practice. We might use those risk mitigation tools or bias mitigation tools to run diagnostics and then apply appropriate safeguards to address those issues. And then when we test the prototype, we have to decide if we test it with actual users or maybe in a simulation, whichever suits best our needs. And then to collect inclusive feedback. We could go back to the data ecosystem mapping and see, have we actually tested it with all relevant stakeholders who are impacted? Have we collected it in a way that actually gives us enough information of how different user groups or people who are impacted could get out? Do we have all the experiences, let's say, available that, or experiences collected that could inform us on whether our final product is responsible or not? But often your best tool is your own brain. So these are examples of some nice, helpful canvases, and Jelena will talk a bit more about technical tools. But of the most important is just to practice your thinking, practice your ability to recognize these issues. So we need to practice actively recognizing the consequences of our work, whether it's to develop an AI system or to use an AI system. We need to think about who will be responsible for the outcomes. So we have to make sure that in the process, the responsibilities are actually defined. We know what we are responsible for ourselves, and we know if there's an issue, we know who to go for with this. Then we need to think about or actively reflect on the values that we need or want to embed in one product, because there is always some kind of values. For instance, machine learning, or let's think about generative AI models, for instance, there's always some values that are embedded in it, because we are people, of course, with values who develop them. And then we have to figure out the risk management system. What's the process for managing the risks when we have recognized them? How can we perhaps enhance innovation in a way that is beneficial for everyone to encourage human flourishing? So it's not just about identifying problems and issues, but it's also about encouraging the positive aspects that AI can bring. And then when we have to make choices, we have to learn how to justify them. And because we have to make choices, of course, so we have to consciously know that we are making choices. But we, for instance, prioritize transparency over privacy, that can sometimes be an issue. Or if we have to try to make a model more accurate, that might mean that it's not quite as accurate for minority, let's say, than it's for majority. So if we want to then make a trade-off there, we have to justify it and be very transparent about it, about the choice that we have made there. So these are the skills that we don't necessarily have any checklists or tools, but sometimes you just have to practice in your everyday life and make sure that you are actively thinking about these issues when developing or using AI. And you don't have to think about this all the time. It would be super tiring. So you can always think about it in the context where you are working, such as if you are part of an AI development team, for example, then it becomes much more concrete. How do you make sure your algorithm does not lead to discrimination, for example? How to eliminate hindrances arising from ethical dilemmas in the innovation so that we can develop the ethical, beneficial AI? Also, what kind of societal and environmental implications does your technology hold? Did you choose the most optimal or most optimized model or coding language? Would there be a model that is maybe a less energy consuming that we could choose that would be quite as accurate? Or maybe we want to make a trade-off that we take a little bit back from accuracy and be more environmentally friendly, these kind of questions. Or also, like talked about, is the model more accurate for some part of the population than another? So these are examples of the dilemmas that an engineer, for instance, or a data scientist might face in their work. And there's this one nice quote from this report called Addressing Ethical Dilemmas in AI, that engineers have raised their issues that they have found in their work in ethical AI. So we really need to start to maybe change this practice, that we have to be aware and knowledgeable about these issues that we have in AI. In the context, I wanted to bring a couple of examples from data practitioners that I collected a while back for one lecture that I gave. And it was about skills that we need now that we have a lot of these different generative AI applications. So what are the kind of, beyond just the technical coding skills, what are the skills, the kind of the human skills that are very much needed in the field of tech? And these were a couple of quotes. For instance, understanding risk, harm, and anticipatory trauma. These are, to do this, we have to practice skills. We need understanding where the generative AI is not reliable or can make errors. And here we don't necessarily have very effective technical tools. And I especially like this one. The generative AI systems have learned from us humans using material we created. So there's nothing in their skills that you can't learn and do. So basically, in addition, you have the ability for logical thinking, reasoning, ethical perspective, and many others that are missing from the core of the AI system. So even though we are sometimes thinking that AI can do many things, with AI we can do many things automatically, but at the same time, practicing these skills have become even more important now in the age of generative AI, let's say. And lastly, to finish, it's quite an intense set of slides. We need to build a responsible ecosystem. So you don't have to do it alone. You always have a network. You can always turn to professionals who are working in sustainable AI or responsible AI. Like, for example, I'm working now for Solita, who is really concentrating on building responsible, sustainable AI from these different perspectives and ethical AI. So if your organization needs help, we are happy to help. There are many others as well. There are networks like Women in AI, where we talk about discrimination in AI and try to encourage diversity. So if you need help, want to discuss, find your people, find your network, and there are always people who are happy to help with practicing these skills. And part of the practicing is to communicate with your network and build discussion with people around you. So make sure that your AI ecosystem is full of people who care about responsible AI. But we have maybe 2 minutes left before before I give the floor to Jelena. So if you have any short questions or comments, feel free to ask. I will also check the chat now too.
All right, you should be seeing my my screen now.
Yeah, everything is perfect.
Yeah, well, hello everyone, and yeah, I guess I first have to start by thanking Sala for her presentation. It's been really inspiring, and really inspiring to start thinking about, okay, well, let's do something about this. How do we do more about responsible AI? And that's what the second part of the presentation or my presentation is about yeah, essentially how AWS approaches it, primarily what are the tools on AWS and recommendations from AWS that you can follow or that you can use if you want to develop AI in a responsible way, in a fair way. So yeah, let me just get started with that. And another very important thing, I'm not on my own here from AWS. We have 3 more solutions architects who will be helping you in the lab or answering your questions. So I'm joined by 3 brilliant architects, all here in the Nordics, working from AWS: Asma, Alison, and Xiaoyi. So yeah, you can ask them in the chat or later in the labs. And yeah, myself, my name is Jelena. I'm Principal Solutions Architect with AWS. I'm based in Copenhagen in Denmark. Right now I primarily work with renewable energy customers of AWS, so big renewable energy companies in Europe. It's also, I think, an important area of work, just thinking about sustainability and future. My background is also a lot in data science and machine learning, so I'm helping some of our Nordic customers also outside of the energy area with AI and ML, and that's also why I'm today presenting at this meetup. So yeah, it's four of us. Feel free to ask questions to me now, to ask questions in the chat later in the labs, or also to reach out after the presentation. You will get all the materials. So just briefly, the agenda for today, I'll give a little bit of introduction, how responsible AI looks on AWS, then talk specifically about the tools that AWS has to help you if you're developing AI, to measure is it fair, to detect bias, to mitigate bias, to explain models, to understand why models are giving certain answers. I will introduce SageMaker Clarify, which is our main tool, both for explainability and for detecting bias. And after that, we'll have a lab where you will get pre-provisioned AWS accounts, so you don't have to use your accounts if you have them, or if you don't have them, you can use these accounts where you will already have provisioned SageMaker, and you will just be able to start working there without cost for the duration of the lab. So this is the agenda. And the first part is the overview of responsible AI on AWS. And I think here, essentially, I just want to say that AWS understands the importance of AI and the responsible AI, and really takes that responsibly. And you can see here some data, I mean, how much AI is growing and how much its reach is growing, and how it now plays a part in every part of an organization or in our lives. And with that growth, I think comes responsibility, and that's what AWS also recognizes. I also have a slide here, how AWS sees responsible AI. I think it's fair to say that this is still an evolving area. So we have there are different definitions, different ways to structure and say what are the pillars of responsible AI. I think this is fairly similar to what Sala presented, but for the moment, AWS chooses to focus on these 6 pillars when it comes to responsible AI, and then to work and build tools to help AWS customers based on this. Obviously, it's about fairness, explainability, privacy and security, governance. So exactly what you have heard from Sala just before. And then another point is that AWS really wants to support responsible AI across the entire machine learning lifecycle. So both before you're doing something, when you're just looking into your data, preparing your data, that also afterwards, when you have your model, when it's giving predictions, so throughout the life cycle, both with our data preparation services, with our model making services, model monitoring services, and that's the technical part. And then in addition to these services that you can use it, that have these features related to responsible AI, we also have just the expertise, so our specialist solution architects who can help, who you can reach out to who are helping different customers, and also guidance on AWS website, as well as training options, including a lot of free online training. So yeah, supporting responsible AI throughout machine learning lifecycle. I'll just highlight one of the relatively newer things that we have for our services. We have these AI service cards, which are a way to transparently show how these services are used. So you can see for each of the services, for each of the relevant services here, what is the intended use case, what are the limitations when maybe you shouldn't use it for certain use case, what are the fairness considerations. So, for example, if you look at the one that is recognizing that is doing speech to text, it can tell you that maybe it's the best if you are speaking English with a US accent, and then what kind of accuracy you can expect on for that, whether you can expect lower accuracy for certain groups or groups of people or not, and then yeah, it can also give you transparency. How can you know why a certain transcription was chosen from a speech? So it can give you several options, tell you confidence it has in each of the transcriptions, so you can gain some transparency, some explainability into how this working. So yeah, if you're going to these AI services, then you can use AI service cards to know that you're building on top of transparent service that can be used in certain use cases. You can see this at AWS website. So this has been a bit of a general introduction about the importance of responsible AI and what we are doing overall in that domain. In the next few slides, I'll just tell you a few of the specific metrics that you can use on AWS to detect bias, to detect whether something is fair or not. So you have them built into SageMaker Clarify. And of course, as we talked about, so we can try to detect bias in the data itself, or bias in our labels for some data, or post-training, we can try to detect bias in our responses. So I will show both examples of both groups of metrics, and then we can use some of them later in the lab. So yeah, pre-training, post-training, and also we should note that even if once you create a model, you look at the data, you create a model, everything seems fine, we still need to monitor it for the drift over time. So maybe some of these fairness bias metrics change over time. Maybe predictions become better or worse, or data becomes better or worse for some groups of people, for example. So it's just something that you have to monitor throughout the life of your model, and you have model monitoring tools from AWS to do that. So yeah, some of the typical metrics that you use for bias, you can look at class imbalance. So if you have more or less data for one class. In our lab, we will use some car insurance data set, but in general, it can be any data set where maybe you have much more data for men than for women, or vice versa. So yeah, you get this ratio, and you can decide whether to do something about it, whether it's acceptable for your use case. Another thing that you can, another metric that you can look at, so you can look at the labels in a data set. So maybe you have, for example, equal number of men and women in your data set. If we're just simplifying and saying that there are two classes, just as a simplifying example, but maybe the labels are different. So maybe in one of the data set there is much more of positive labels, and in the other there is more of negative labels. So this would also, and maybe it's expected, maybe not so, but this is also a metric that you can take into account when deciding if you want to keep building on that data set or to do something about it. So these have been metrics that you can apply pre-training while you are exploring your data. And then we have also metrics that you can look at post-training. So essentially the first one would be, does your model after it was trained favor one class over the other? So if you are deciding on giving, approving bank loans, do you approve bank loans more to people of certain nationality or people from a certain city or anything like that? So you can look at differences of positive predictions in one class versus the positive predictions in the other class. And then in some kind of models, it makes more sense to look at accuracy difference. So is the model working better for class than the other, just to maintain this fairness? So you just look at proportions of false positives and false negatives if one class has than the other. So again, something that you can choose. And there are other metrics you can look at. Clarify, you can look at AWS documentations. What are the metrics that you have out of the box other than, and then of course on top of that, you can create your own code to detect any metric that you are concerned about. And I think it is a little bit out of the scope or time that we have here to discuss all the ways. Typical solution would be just to go back to your data set and try to see if you can balance the data set in some way. I'm showing again an example from SageMaker from Data Wrangler. While you're preparing the data, you can ask it to balance the data with different methods. So first you need to say according to what column, what feature it needs to be balanced. So maybe it's gender, maybe it's something else. And then you can choose the algorithm. So there are the obvious ones. So random oversampling, which means just copying more of the minority class. Undersample, having less of the majority class in your data set. And then these obviously have some disadvantages. So they will make your data set balanced. But if you're undersampling, so if you're discarding a lot of data from majority information, so your model might have lower accuracy. And maybe you're fine with that. As Sala mentioned, maybe you do need to make this trade-off between accuracy or fairness. Maybe that's not the optimal approach here. The same for oversampling. So you will be giving more importance to maybe just a few data points which can have disadvantages. Or you can use this synthetic technique, synthetic minority oversampling, where you are in a way creating new data points similar to the existing data points from the minority class. So different ways, and you can use those built-in transformations. You can write your own transformation that would make your data set more balanced. So that's what you can do before the training. And then once you get into the training and into creating a model, you can just make a choice what kind of model you're going to use. So you can, obviously, anyway, when you are creating your models, you will probably try different algorithms and different approaches. You'll try to see, are tree-based models better than linear models for your problem? And then you can also see that better could also mean, are they producing less biased results? So you can balance the data, you can choose different algorithms, so the obvious ways to address bias. And then, in addition to bias, what you also need for responsible AI, for transparent AI, is to be able to explain your models, mainly to explain the predictions of your models. And then the different reasons you need this. It might be to meet some regulatory requirements, but it is, even if you don't have those requirements, I think it makes sense doing it to build trust in your organization among the users of the model or business sponsors of the model. Then if you want to augment it with human decision making, then you will support that it making explainable why some decisions are being made. And also for debugging, for improving your model performance. If you see that some feature seems much more important than what in reality should be, you can detect some errors in your model training this way. If you see that some feature which is, I don't know, IDs in your data set is gives certain results. Yeah, so obviously model explainability very important. And then again we come to the possibility that we might need to make some trade-offs. Unfortunately, the models that are more explainable or more intuitively immediately explainable, with understandable impact on predictions, tend to be those that are simpler and in some way might not be that accurate. So if you have a linear model, you see exactly, okay, this is the coefficient next to this feature. This is the importance of it. Also in the decision trees, fairly simple models, you can see how a data point goes through decision tree, where does it go through each branch. So you can see what made the model make this or that prediction. And then when you come to some more complicated but often more accurate models, like ensemble methods, where you just have a lot of models together. So you first need to see how much they are contributing, or when you come to neural networks, which might be a little bit of a black box for you, then that's less explainable at first sight. So it is a trade-off that might need to happen, but luckily there are ways to explain decisions made by all kinds of methods. And of course we can look at two types of explainability. So both at global explanations, so just in general, which feature is important, which variable is important for a model, and that local explanations. And these are often more interesting. In this specific case, maybe for this specific person, why was this or that prediction made by a model? And then here are just some of the examples. So why a bank model, whether to approve a loan or not, gives a certain answer, or like because of what word did the sentiment prediction, sentiment model give their sentiment to passage of text. So, and then there are a lot of different techniques to do this. One that I will describe here is, and that you can use in SageMaker Clarify, is based on Shapley values and taken from game theory. So essentially, if you imagine a game where different players can collaborate to play a game together, and then you want to know how much each of the players, say in a team that is playing, contributes to the game's payoff, contributes to the results, contributes to how often, say, that team wins. And then I'll just briefly explain intuition on this slide. So you can see, for example, that player P1, if the player plays the game on his or her own, the payoff is $25 in this case. P2 gains 100. So the simple thing would be to say, it seems that player P2 is 4 times better. But then if you look at example number 5, when P1 and P2 joined together to create a team, they won 550. So that's 5 times more than what P2 can do on its own. So here, P1 contributed a lot, made the payoff over 5 times bigger. So yeah, it's obviously helping a lot. And that's the intuition here, is that for each of the players, we need to see, like, on average, how do they help in a team. So P1 helped over 5 times, when in a team with P2 helped 4 times. when with the P3 and similar. And sometimes players can also negatively contribute to a team. So if you see the example number 7, well, here P2 and P3 together, these two players are performing worse than individually. So it's a negative contribution to a team. And essentially, this is the intuition behind it. We are not going to go further than this. So essentially for each player, you just look on average across all these possible teams, how they contribute. In our case, of course, it's not players, it is features. So you can imagine just different players are different features, different variables, different columns in your data set. And as a payoff, you can see the outputs of a model. So you can create a model with only one of these features, then a model that has first and second feature, then a model that has a second and third feature, see the results, compare that, and that's the intuition between explainability. And then that tells you, well, this feature is this much important in the model and this much important for giving an answer about this specific data point. So this is something that you can do in SageMaker Clarify automatically, and something that we will do together in the lab afterwards. Yeah, so this was one of the possible ways to explain models, explain contribution of different features to the model. And I have mentioned several times, the key tool we will be using is Amazon SageMaker Clarify, and it can do both explain your models and assess your models and your data for bias. It can look into bias during data preparation. So it has this different pre-training metrics built in, different pre-training detection methods. So you can detect bias in the data. Also, it can detect bias in your trained model. Again, it has these post-training metrics, and it can query your deployed model or the model or the copy deployed for it and detect bias. It can explain predictions global, so global importance of a feature, local, why was this individual prediction made because of what feature was an individual prediction made. It can do that also for these models where you don't really know what's inside them, so they're almost like a black box inside, but it can still work and just by querying their outputs with different features, explain their predictions. And also we have SageMaker Model Monitor to continuously monitor your deployed model and then alert on changes for these important metrics for bias. And also you will see it can output some reports that you can use to understand better what the model is doing, but also if you need it for some sort of auditing or communicating with the rest of your team. And the next slide is also basically showing that how this works, how throughout the model lifecycle you can detect and try to mitigate bias. So at the beginning, for when you're preparing, collecting data, you can perform bias analysis. You can use Data Wrangler to try to transform your data set to get rid of this bias, and the same after you train and tune your model, when you deploy it and when you continuously monitor it. So we will be using SageMaker Clarify in the lab. And then, yeah, speaking about the lab, as we are approaching time for the lab, so I'll just explain how we will be doing that. As I mentioned, you will be given AWS accounts where you can use SageMaker Clarify and SageMaker in general to do this. We'll be following a tutorial, and you have links both for joining the lab and for accessing the tutorial in the Q&A here in Zoom. So essentially, you will join the lab. Then that will enable you to access an AWS account. So you will access that, and in front of you, you will have AWS console, where you will see all the AWS services you can use. We will be using SageMaker. And then once you are there, once you have SageMaker in your AWS account, we will not be following the instructions in this specific lab, which is because it's more about general SageMaker lab, but we will switch to the tutorial that you also have the link for and follow the steps in that tutorial. And I'll have slides also here that you can follow that and and join the lab. And then in the tutorial, we will do sort of a full thing. We will train. We'll have some data. We will train a model. We will use SageMaker Clarify both to look for bias and to look for explainability of that model. And then we will deploy that model and try to query it to see that it's working. So yeah, as I mentioned, you have your own account, so everything is there that you need to complete the workshop. You'll be given an account. Then you can also follow in your own AWS accounts if you want to. Just you will need to have SageMaker Studio provision there. The account will be available only during this workshop. So unfortunately, once we finish the labs and the workshop, this account will be terminated. So you will not be able to continue working in it. The tutorial will still be available, so you'll be able to look at it or use it in your own account. But yeah, this account disappears when the lab is done. You will see that you are only the infrastructure is working in a specific AWS region. So once you are in AWS console, you can choose in which region you're working. So just AWS global infrastructure has regions in different parts of the world, and then you can use resources in specific region and of course across regions. So here you will be working in an US region, and just as long as you don't touch anything related to that, everything should be working. The others will be blocked. At the beginning, you need to accept terms and conditions, and it's just some standard text, just noting that you shouldn't be uploading any personal confidential information to the account, and the tutorial definitely doesn't ask you to do anything like that, but you still need to click on I agree somewhere. Yeah, so once you click on this link that you also have in Q&A catalog workshops AWS join, you will be presented with this screen where you can click on the first option to get one-time password to your email. So you can click on this, and very quickly a password will arrive to your email. And then after that, you can join, and you will be asked to input event access code. So it's also something that you have in the Q&A. You have this 12-digit code in this format. Click on next. Then you get these terms and conditions that you need to accept in order to join further. And this is the interesting part. So these are just example slides, but what you can see here on the left, once you are in the workshop, you will have this part on the left near the bottom, AWS account access. So that's important. You will click on this open AWS console, and then in a new tab, you will get AWS console. So you'll get your AWS account where you'll see all the AWS services, and you just stay and work there and can forget about the rest. So yeah, so this is how it will look like more or less. You will get AWS console. It will show in which account you're working, in which region you're working. You will see what are some of the services SageMaker that were recently accessed. You will be able to click here and see what are all the services that are there. So just a typical dashboard of an AWS console. Yeah, and I think this just this is so. One important thing to note is that we will not be doing the full tutorial. The first step in the tutorial is about provisioning SageMaker, and you already have it in your account. So you can skip the first part, and also we don't need to update SageMaker because you have an updated version with some libraries in the data science image already. So basically, we start from step 2 in the tutorial, and we won't need to do everything. That we can skip some of the configuration parts, but you will see that on the screen, or get help from my colleagues in different breakouts. Yeah, so I think this was the introduction for the lab part. I'll pause here, see if we have questions, and also prepare for the labs.
We don't have at this moment questions. I think if someone has, we can find them from Q&A session later also. So we have about 5 minutes break now, and we will continue. Yeah, 2:10. In Finland, I don't know where is people where from, but in Finland, yeah, in Finland we have to so 10 in 5 minutes. Let's see you.
Sounds good. See you in 5 minutes. Let's do that. I will share my screen and basically alternate between my AWS console and the tutorial that we are following that has more explanations about everything that we will be doing. Maybe there's 2 things to note. So we will be using AWS console, which is essentially this browser interface for AWS, where you can just come there, click on services, click on options that you have there, also copy or put in code. So that's the console. That's one of the ways to work with AWS services. You can also work by, for example, calling APIs, so sending requests to AWS APIs. But for our purpose, it is the simplest just to be in the console and have this browser environment where we will be working. The key AWS service that we will be using is Amazon SageMaker. So that's and I think you're familiar if you have been at previous workshops with it, but this is the key service from AWS that supports the whole machine learning lifecycle. So from having data, transforming data, extracting features, training models, deploying them, monitoring models, looking at explainability of models. So you can do all of that in Amazon SageMaker, running experiments thanks to SageMaker notebooks, for example. So that's the key service we will be using. So we'll be using the console, SageMaker, and then the specific tutorial that we will be following, and you have the link in Q&A, is where we are given already a data set about car insurance claims. It is a binary classification problem, trying to classify if an insurance claim is fraudulent or not, or if it's a legitimate car insurance claim. So we will just use that data set, train an XGBoost model, so train an ensemble model based on tree-based models to do this binary classification. And then we will be using SageMaker Clarify to both look for biases, so to produce this report on fairness, and also to look into explainability, so to tell us which features were important for something to be classified as fraud or not. So if that makes sense, I'll start sharing my screen, and you will see where we are. Yes. And this is not the... Okay, so I'm assuming that everyone who is following along is on this page where we have AWS console. And as in the previous part, you can ask questions by saying your question. You can use the chat, and we have several AWS Solutions Architect here to help with your questions. But let's assume you are here, you're at AWS console, and then you can see your account, which user you are, in which region of AWS you're working, and some other useful things, hints how to get started with AWS, any notifications, costs that you have incurred so far this month can be quite useful when you are actually working. And you can also customize your dashboard, but this is how it looks like normal. And you can also click here in the upper left corner and see all kinds of services that AWS has that you can use across categories. So we can also explore that, but for now we will focus on following this tutorial, and that will for that we will just click here and open Amazon SageMaker. Another thing to note, we have a few steps in the tutorial that take some time. So at 3 points, we will have steps that take about 10 minutes to finish. It will essentially be model training, as that takes time. And then it will be clarify, looking into fairness and looking into explanations, as that also takes time. that Clarify simply has to ask the model for a lot of different data points to get answers before coming up with this report. So we'll just have these 3 pauses, which will also be a good opportunity to ask any questions. So this is where we are. You should have SageMaker and SageMaker Studio, which is where I'm clicking now. And SageMaker Studio is this fully integrated development environment for machine learning. To get started, we select user profile, and what's here, workshop user, that's us, that's good. And we open SageMaker Studio.
And Helena, I have one comment to presentation. So when we open this console, maybe no one, or maybe someone has this SageMaker already, and someone not. So if you don't see it, you can put in search SageMaker, and then the same steps. Yeah, here Amazon SageMaker, the first one.
Yeah, thanks, Anna. Good point. So if by any chance someone didn't have it, this is how to get there. And here now we are in SageMaker Studio. And again, you have these options for quick things to do. We will be we'll be creating a new notebook. So these are basically like Jupyter notebooks, where you can create a notebook, then you can choose the environment for it, which image, so which like container image it's based on. We will choose data science because then we already have pre-installed a lot of the libraries that we need to work with data science. Python 3. You can also, so you can just keep the options that are already here. Instance type. So yeah, this is basically a virtual machine that is behind your notebook, and then depending on what you are using, there AWS has, I think, the largest, the broadest choice of different virtual machines, optimized, some of them general purpose, some of them optimized for different workloads, maybe compute optimized or optimized for machine learning. So we will use this one, the medium-sized one that we have here. Just say select, and then a new notebook is being created. And now we are ready to put some Python code here. What we will be doing is following this tutorial. So you also have a link in the Q&A. On AWS website, you have this train a machine learning model tutorial. And this is a tutorial that is focused on using SageMaker Clarify. You have an overview, which is what we basically covered so far. So what are we going to do? We're going to train and evaluate the machine learning model using SageMaker Studio and Clarify. There is a data set with the features and the column indicating whether it was fraud or not. We will use XGBoost, which is an open source framework, and build a binary classification model to see to predict the likelihood of a claim being a fraud. And then we will evaluate it for bias. We'll look for explanations for it. As I mentioned, we will skip the initial steps. So the step 1 is to set up SageMaker Studio. We are skipping that as you already have it provisioned. Also, that would also take some minutes, so we are skipping that. And then we are going on the step 2, where we are opening a notebook, which we have already done. So we have a new notebook. We are choosing the data science type of a notebook. Normally, you would here upgrade your SageMaker, but since we just freshly provisioned accounts for you, it is already updated. And then the first step that we need to do, and you also have a pandas library. So basically the first step that we need to do, we will copy this code to install XGBoost. Library. So you just copy the code here in this on this place, and then you can press Shift and Enter, and this will tell you that it's executing. I'm executing it in a quiet way, so we don't see all the output. And nice. So XGBoost is installed. So we have installed the library we will be using. And in the next step, we also just need a few more things for our environment. In AWS, we normally use S3, so simple storage service, to save any data, to have data that is used by the model, to also save some model outputs if we want. So in the next piece of code here in 2.9, we are basically just importing the key libraries we will be using. So to work with SageMaker, to work with the storage, typical Python libraries for working with data, and then setting that up. So basically, we're just giving the names of the buckets we will be using to put data, where we are getting data from, where we will write data, what will be the file names, and similar. So you can always have this here copy button. So I have all the code snippet copied, and I'll put it here, and again press Shift and Enter, and you see it working, and it is done. So you can see that little star here while something is still executing. Now we see that it is done, and we have set up these basic configurations, like where we want to put our train and test data and similar. This just again points you to some of the parts of the code that we just executed, where the files will be, and then so this was for the data essentially, and then here we will use this code to name our model, name our training job, name our tuning job, or give prefixes for that, give the name of our model, say on how many instances we want it trained, and this is not a huge data set, so this will be just fine. How many instances we want to for SageMaker Clarify. So let me just copy this as well. And
Helena, can you wait just a moment, because people still have running the first cells, and actually, for example, for me, I have also one error that it is not run successfully. But I can put this error in the chat if someone from AWS can.
Yeah, so are you installing only XGBoost, or you're trying to install Pandas as well?
Pandas as well, yeah.
I think it's the Pandas that is creating a problem.
Okay.
Because you already have it, so you could just delete the second part, because the original instructions ask us to install XGBoost and Pandas with specific versions. If you just put this, just installing XGBoost, not asking for a specific version either, this should work.
Okay, yeah.
And I will wait here a little bit more. But the first part was about setting up the environment. We opened the notebook, installed the XGBoost libraries. That's the only one we need. The rest is already provisioned for us. Pointing, just saying where our data will be, where our all kinds of both input data along the outputs that we want, and then pointing, giving names for our model, saying on how many instances we want to train it, on how many instances we want to query it with Clarify. So that was the second part, and then we'll pause a little bit here and come to the next. Actually, I will come to the next part because then we will have a natural pause while the model is being trained. So once we have set this up, we can go into training. So we will train a model, and then we will evaluate it with Clarify. So this step 3 is about training it and tuning its parameters. So I'll just copy the next one where we are defining our training process. So here we are just saying what the algorithm you are using. For XGBoost, you will need some of these to see, for example, what is the maximum depth of your tree, what are the metrics you want to evaluate it on. So in this case, it's area under curve, but you could do something else. And similar. So yeah, you're specifying different parameters pointing to the training data, pointing to which column is where the label is, the fraud column. So here we have obviously split on training and validation data, so the same for validation data, important parameters, and then we have cross-validation here. So XGBoost model has this cross-validation. And then, yeah, here it will just be, model will be that we use XGB library, train model, depending on all these parameters that we put there. Once that happens, we have the predictions, we have the validation predictions, we have our accuracy score here, both for the training data and for validation data that will be printed, and yeah, and the model will be data, and the model will be saved. So I will copy this and put it in the next cell. Here in the tutorial, you can also get some more explanation again, what are the relevant parts of the script, what are the most interesting parts of the script. And then, so now we just prepared our training script. Now we want to call this training script to actually do the training. And yeah, that's what the next part of the code gives us. Again, in the tutorial, you can see what are some of the choices that you can make. Explaining specifically for the XGBoost algorithm, what are some of the important hyperparameters, so what will be tuned here. And then you can just give the range, and the tuning hyperparameter tuning job will then search within these ranges to find the best parameters. So I'm going to copy that code as well. And yeah, so we are here setting up the tuner. And this part is practically the same, no matter what, for a lot of models you'll be developing. So you'll just change what is the name of the algorithm that you're using. Is it XGB? Is it something else? The parameters might be slightly different, but yeah, this is just always there. And then we have this fit method. So we're launching hyperparameter tuning job by calling that. So we are saying input data, validation data, and then we are calling the fit method to actually, after we set all this up, to start hyperparameter tuning. So this will take some time. The tutorial says it will take 13 minutes to complete. So that's also time to catch up if you're a little bit behind in the tutorial, or just to look a bit more in the explanations here if you're interested in that, or look a bit more in your AWS account if you want to look a little bit more how AWS console looks like. But this is this is now going to run for about 10 minutes, so training for this. And you can also, if you want to go back to the console, so not to be here in the studio, but to go back to AWS console, and then you can on the left, you have different parts of SageMaker. Studio that we are using, then some configuration. Jumpstart is the part where you can already get some pre-made models. Here you have, for example, foundation models for generative AI. So you can see what you can find there, that you can just start from pre-made models, ground truth for labeling, notebooks, processing, training. We can take a look at training and see, for example, hyperparameter tuning jobs. Do we have any running jobs? And you can see here what's going on. So you can see that I already had one hyperparameter tuning job. I did this. I tried this tutorial earlier today, as you can see, and it ended in 6 minutes. And the one that you can see here is the one that I just started. So you can also just follow the running jobs and see whether something failed, whether it's still in progress or similar. So and then the same is also for training jobs. Inference, once you deploy something, you can look at the endpoints, you can look at the models that you have, and also marketplace, where you can get some data or pre-made products. So that's how Amazon SageMaker console, and we are still here, and you can see this cell is still running, and it will be like that for some more minutes, and then so we are here at 3.7. We saw that we have this job running, and once it finishes, we will be able to see the results. Okay, I'll make a pause now and wait for that mine and yours training jobs are completed. Yes, so the tuning job completed, and then we saw that also in the SageMaker console. We followed its progress, and here we can get some summary results of it. So I'll just copy the next part in the cell, and it will give you some data about what just happened, and the combination and hyperparameters that had different performance. So in different jobs. So you can see here the best value was 0.75, and for what hyperparameters it was achieved. So max depth was 5 and similar. So these are specific for the XGBoost algorithm, but you can also see what were the best parameters. So now we have a trained model, and then before we deploy it, we need to check if there's any bias in it, caused by the model or caused by the data that you have. And that's when we start using SageMaker Clarify to explain, to tell us which features were used to make decisions. And also we could use it to look into the data. Here we will focus on post-training metrics. So bias metrics after training, and the SHAP values that we talked about in the first part for explainability. So as I mentioned, SageMaker Clarify uses a model that is deployed to an endpoint, and then you can create this model in different ways. But here it needs to be created so that SageMaker so that Clarify can query a specific model, can send queries to a specific endpoint. So this will just create a model from our training job, and then we will use that for SageMaker Clarify. This was quick. So we have a model, and then here we are setting up SageMaker Clarify. So so it is essentially configuring what Clarify should look at. What is the train data? What are the features, the columns in the data? we're also saying which is the important, the label column here, and then saying which model should be inspected. And then, of course, the model is producing probabilities, so we are just assuming that probability over, here we are saying if it's probability above 0.5, that will mean that the model is saying something is a fraud. And then, yeah, configuring bias here, especially here looking whether this column, whether a customer is a female gender, whether that's important for model predictions. So yeah, configuring clarify. And then we can use that to actually run this job. So it will just use the configuration that we already made, and then giving these metrics. These are the metrics that we mentioned also during the talk. So class imbalance for pre-training, whether there are more or less examples from a given class, difference in positive proportions or predicted labels as the post-training method. So seeing if we are more or less likely to say that something is a fraud for a minority group. So we will copy this, run, and then again we will have a pause here as a clarify just needs to call the model for a lot of different feature combinations to check for bias and for post-training primarily. So we are waiting here for the clarify. We are running a clarify job and waiting till it says 12 minutes for this to complete and to save the outputs in a bucket. I do have output from when I have previously run this, so and we can just use the time to go through these outputs. So while we have this 4.3 code running, 4.4 would copy the output of this clarify job to here to your SageMaker environment. I already have it, so I'm just going to show it, and you can see how a clarify output looks like. So this is a report that you can use to improve your model. This is a report that you can maybe share for auditing or other purposes or understanding purposes with your coworkers, colleagues, teammates, anyone. So it first just tells you about the data set, how much fraud there was observed, how much was predicted, and here it seems that the model is just predicting that it's predicting that 5 instances are fraud. So this is maybe not a particularly good model at the moment, but it doesn't matter for our purposes. So no, actually it is because the test set is smaller. Yeah, anyway, so you can see what was going back to my first explanation, the model is just not seeing a lot observed and predicted. And then we have chosen this column, whether it's a female customer, and then just looking at the distribution of that. It first gives you model performance, so whether it's a good model performance. So, and here we have the accuracy, which might not be the overall accuracy might not be the right metric to look at if you have quite unbalanced data set, in the sense that if you don't have a lot of fraud, a model that would predict that nothing is fraud will still have quite good accuracy. So perhaps not the right metric to look at, but that's the first obvious one to look at. So this was just more about the model in general performance, and then after that we can see bias metrics. So you have chosen some pre-training bias metrics, and then you get the report on whether there is bias according to this metric, even before making the model, even in your data set. And then, yeah, for specific metrics and specific values, you can decide if it's acceptable for you, or if you want to, for example, by using a data wrangler and some of the algorithms to make your data set more balanced. The next part of the report is about post-training metrics. So whether the model predicts more fraud, in this case for male or female or for female or non-female customers. Yeah, it seems that there is no difference in proportion. So it seems that it's okay, at least post training for this. And then you can also just in the appendix you just get what configuration was used to run this model. So what were all the features we have been using in this, and this is a synthetic data set. So what were the features that we had, starting with fraud, which is the label, and then data about the car accidents. We were using this column, customer gender, female, so we had 3 columns, other male and female, and we were using the female column to check for bias related to this column. These were the metrics we used. This was the model that we used, and just technical parameters that were used for the analysis. So this is the bias report that you get from SageMaker. Clarify, and this is how it looks like. It will be different for your specific data set and depending on the metrics that you choose, but overall it looks just like that. It looks something like that. And sorry, I'm going to check. Yeah, so here it is still running. So we will need some time before we can get to the next step. And in the tutorial, in the rest, you can also see there the tutorial's comments on the report, so that there is some imbalance regarding customer gender. That you can, there are some options that you can do to correct that imbalance. Yeah, so we are now waiting for this job to finish, that you get these reports in your accounts.
Should I pause our recording, or what are you guessing how long it will be?
We're probably looking for 5-6 minutes, but I can also just continue as and show the rest that I had run previously, and then we can have this running in the background. So yeah, so this was about bias and fairness. In addition to bias, SageMaker can do explainability checks. So looking at what features are important, and this would again be one quite long task. So it's similar. Clarify is querying and deployed model at an endpoint, but this time looking for explanations. And then I also have the explainability report that I got, and this is giving giving us what features are important. In this case, we use this SHAP explanations that we discussed previously, but you could use also different ways of explaining. And then it is just this displaying the 10 features that are the most important for deciding if it was a fraud or not. Obviously, customer gender, male, how long someone was a customer, how many different insurers there were in the past 5 years, number of claims previously, witnesses of that accident. So I guess it all makes sense in some way. and then you can get just more details for individual instances. And you will get this report in your account also once this code is run. And the same for the previous one. So what were the configuration parameters that we used here? So just telling again all the features, what was the label, what we did. So we did SHAP values, and then how many samples. So this was run on 500 data points, and then just how do we aggregate the importance of a feature across these 500 data points. So this is the explainability report, and it tells you which features were the most important for determining whether it was a fraud or not. And then, yeah, based on this, you can explain what's you can have some transparency about the model. If you see something here that you don't expect, can't explain, you can also go back and try to see if there was some issue with your data when it's when something completely non-intuitive is showing here. But yeah, so this is the other kind of report. You can also see some of these reports when you go to experiments that you have. So even if you didn't copy them, here in SageMaker Studio, if we go to this home icon and then look at experiments and some unassigned runs here, so you can see different experiments, different runs. In this case, we have clarify bias and explainability runs, so we can take a look at the clarify bias here and see what happened. So we see what class imbalance we had, see what other metrics is telling us. So you can just get a report here in SageMaker Studio. So other than the PDF report that you can explain, that you can export, you can get this bias and explainability data also here when you look at these runs. So this was a bias run, and also we have the explainability run that you can see here important features in this case, but also get all the resources from AWS about how to understand model explainability, what are the metrics, what you can use. So just also hints and links if you want to go deeper here. And this, yeah, in my case, this is now completed. So we could go to the steps before and copy the report. So this should now work. That you can copy the report to see it locally in your SageMaker Studio. You can see it if you go here all the way on the left, and this like folder-like icon, that's your file browser, and you can tell you what files you have here. And yeah, now that you executed this command, you should see this clarify bias output file, and you can just open it by clicking on it, and you can then inspect it. Yeah, and here we have the explainability code that now I won't run to save us 10 minutes, and you could do the same. So you could have the explainability output in your among your files. And then, yeah, as I showed, you can also see the results of these clarify runs in the experiments part in the studio. Look at unassigned runs and then see what you have and export as a PDF if that's what you want to do. And you can also visualize explanations for different by SageMaker Clarify. And this will give you something like here in the tutorial. You can see, and this was example number 100. So this is a local explanation. What you have here is a local explanation for one of the one of these 500 data points. So we run clarify explanations on 500 data points. This is pointing one of them, example number 100, and you can see for this specific customer what features contributed to model's decision whether it's fraud or not the most. And here we have highlighted again whether it's customer gender male, incident day, vehicle claim, then a number of injuries, and then so what happened is that Clarify did this for 500 data points and aggregated that, so this will not be the same for some other customer, maybe some other feature had more importance or similar for determining whether it was fraud or not in the end. So you can see globally important features and locally for a given data point which features were most important. And then so we have trained the model, we have inspected it for bias, we have explained its results. So we can maybe go back and change the data, change the model, or if we are satisfied for our purpose, we can deploy the model. And then this is a code that deploys the model. So it deploys it at an endpoint so that you can query, that you can send essentially API requests to get predictions for given test data or for any given new data that you want to do. You can also see that in deployments that you have something. So if you go back to SageMaker Studio, look at deployments, look at the endpoints, you'll be able to see if any endpoints were deployed, if you have a model that is deployed. And then in the last part, you can just call the model that has been deployed with new data to get predictions. So here we'll just have some sample test data. We'll just take our test data frame, take 1 point from it, and then send it to the model and see what the prediction is. So you will make a prediction here, and it will also put the true label that we know because this was our test data set. So you'll just get an output that says here model predicted score, which is the probability, and what was the true label. So in this case, if we say that 0.5 is our threshold, the model would say it's not a fraud, and that would be correct. That would be what the true label also is. So that's the part that you do once you're happy with the fairness and explainability of your model. You can deploy it, query it, and just incorporate it in whatever application you have or whatever business process you have, whatever you are doing. You can use this model. And another thing that we won't do today, but is a good thing in general, is cleaning up resources. So normally, if you're not using some AWS resources anymore, it's a good idea to delete them, because otherwise you can get there is a cost of having a model, of having an endpoint deployed, having SageMaker Studio, and then you also have obviously cost reports in AWS. You can set up alerts, you can set up budgets, the maximum cost that you want to have in an account. So there are all the ways to control your cost, but in general, it's just a good idea to delete what you know you won't be using anymore. So that's the step 6 of this tutorial. There's no need that you do that. Also, as I mentioned, once we finish the workshop and the labs, these accounts will be terminated, so it will be automatically deleted, but it's something that you want to do in general. So we have actually come to the end of the tutorial now, but we still have time. So we'll still stay here in the lab so that you can complete this in your accounts, that your accounts are open as we have one more hour in the lab. But I'll stop screen sharing and just answer any questions you might have.
And we would like to thank Amazon Web Service for organizing this AI learning path together with us. So it is time now for conclusion.
First to thank everyone for joining us and following with the workshop. Responsible AI is obviously a very important topic, and I think affecting more and more of aspects of our lives everywhere, as you have also heard in the Salah's presentation. I think the summary of what we do is that what we showed is also how AWS understands the responsibility and importance of responsible AI, and provides, among all the other tools related to AI, provides the tools for working with bias, fairness, and explainability. We ran through this tutorial where you trained the model, inspected it for bias, looked at its explainability, deployed it, hopefully successfully. And this is, I think, just a starting point. So you can have this as a starting point and look at more resources, other resources, or AWS resources. As I have showed you, you have already in your SageMaker Studio links to relevant white papers, relevant tutorials from AWS. We also have different workshops and training, and you can reach out to me or my colleagues. So just feel free to do that after the workshop, to reach out with anything related to be it responsible AI, be it AWS. Don't be shy. Reach out, and thanks for joining, and also thanks for my colleagues for supporting the workshop.
We have also comments in chat. Yeah, there are very great sessions. Thank you very much.